Hello everybody, so in this video we will be looking at a problem named as tiling problem 2. So the problem statement here says that given a floor of size n cross m, so we are given a floor of size n cross m. So we have to find the number of ways to tile the floor with the tiles of size m1 cross m. So we are also given tile of size 1 cross m, and we have to find the ways in which we can put these 1 cross m tiles on the floor of n cross m, and tiles can be placed horizontally as well as vertically. So it will be vertically like this, 1 cross m cross 1. So the input format is this. We will come to this later on. First of all, let us just look at the problem. So let us suppose we have n equals to 2 and m equals to 3. So this will be our n cross m floor 2 and 3, and our tile will be of 1 cross 3 horizontally, vertically as well as horizontally. So if we see, we can place 1 cross 3 tile here horizontally. We can place a 1 cross 3 tile here horizontally. This is 1 cross 3, and now we are left with 2 minus 1, which is equal to 1. This is 1, and we can place another 1 cross 3 tile here, and the floor is covered. So the number of ways in which we can do it is 1 here. Now if we do it the other way, suppose this is 2 cross 3, we can't put a 1 cross 3 tile vertically here, as it will be bigger than this 2, so we can't put it like this. So the only possible way is 1. Now let us see if n equals to m. So let us suppose it is 2 cross 2. So if it is 2 cross 2, we have a tile like this, and we have a tile like this. So we can place a 1 cross 2 tile here horizontal, and we can place another here. So one tile is placed here and one tile is placed here. So we get one way of doing so, and the another is, what we can do is 2 cross 2 we can place vertically, one here, one here. As we placed first one, we have placed the first one of 2 cross 1, this one. So we are left with this was total, this was 2, so we have placed 2 cross 1, so it is 1, it is 2. So it is, this area is 2 minus 1, which is equal to 1, so we can place another 2 cross 1, so it is another way. So in total we are having 2 ways, right? Now let us take a general example. We have n cross m floor. So this is our n cross m floor, n and m, and the tile is m cross 1 and 1 cross m. So I can place a tile of size 1 cross m like this, and another above this, so it is one way. Now let us see the other way, when we place the tile vertically. So for a moment, let us suppose that n is greater than m, n is greater than m. So I can place a 1 cross m tile like this, let us suppose. So what's left here? What's left here? This area. it will be n minus 1 because it is 1 and it is m. So if we see it, we can get a relation as f of n is equal to f of n minus 1 plus f of n minus m. So we got three cases. That is when n is less than m, we got 1. When n is equal to m, we got 2, and when n is greater than m, we'll find it through this relation. So let us take an example. We have 4 cross 3. So first of all, according to the condition, let me write n is less than m, it will give 1. N is equal to m, it will give 2, and n is greater than m, then we will follow this relation. So what we will do, we will call this function first, f of n minus 1, which will be equal to 3 comma 3. So when we go, okay, we see that n is equal to m, so this function will return 2. Now then this function will be called. So 4 minus 3 is equal to 1, so it will be 1 comma 3. So n is less than m, it will return 1, and in the end we will add these 2 plus 1, so this one will give us 3. So now I'll just code it real quick. We can do it using recursion. The time complexity will be exponential, so we can optimize it using dynamic programming, either in bottom-up approach or top-down. Before that, there was something else, like we have to print the answer of every test case in new line modulo 10 to the power 9 plus 7. So why we use this is, suppose our answer is very big. So as we are given 10 to the power 9 plus 7, so our return type will be long int, and there are certain operations on modulo. Let us suppose if I have a plus b modulo m, so it will be a mod m plus b mod m whole mod m, and same goes for a minus b, it will be a mod m minus b mod m mod m, and same goes for multiplication as well. So let me write it real quick, into b mod m, but this property is not valid for division, So now I'll code bottom-up approach. So now let me go with the bottom-up approach. So I'll take a array of n plus 1, and I'll initialize the whole array to 0. Now I'll just for int of I equals to 1, I less than equals to n, I plus plus. So if I is less than m, or we can add I equals to 1 or m equals to 1, dp of I equals to 1, else if I equals to m, dp of I equals to 2, else dp of I equals to dp of I minus 1 plus dp of I minus m, and in the end I will return dp of n. Okay, we have to do modulo operation here, I forgot. Here we go, let us run it. So it compiled. Let me give test cases as, so values, like I'll give 4 test cases. One will be 4 4, so the answer is 2. Yes, another is 2 3, answer is 1. Now let me give a bigger value, 1025. The answer is this, it will be modulo. And let me give 1 cross 3, it will be 1. So this problem is pretty simple, but that we all need to do is look at these cases and how it works. Otherwise this problem is simple. And thank you for watching the video, and do hit the like button and subscribe the channel.